Hello class, this is Dr. Khanal once again. This is the solution of exam 1. Let me review. This is I chose the B version of the exam 1. It has, um, as you all know, it has short questions, which is 4 points. There 1, 2, the next bit 3, 4 and 5 total, worth of 20 point, and then there is a long question, which is 4 long question, 20 point each. So 20, 20, 20 and 24, total 9 questions. Total is 100. So I'm not gonna do those short questions because those are quite easier one compared to the long questions. I'm here to do basically the long question. All right. Excuse me. Well, in any case, let me review short question also. It doesn't take much time. So here, the short question, the first one is, this is the xt graph of the 4-point PQRS. The velocity Vx is greatest, most positive, right? Most positive is, of course, it is here because this has the most positive slope, because velocity is the slope of xt graph. We know it very well. This one, the velocity is 0. Here is negative, going down, rise over run, and here is also 0. So you know this question. It's pretty simple. By the way, these questions, most of them are from mastering physics. If you have already done your homework, so I'm confident that you have at least done these short questions, all of them correct. Here, this one is that if you pull the bottom quickly, so if you pull it quickly, like fast, then what happens is, because of the moment of inertia, this guy doesn't want to move, so want to stays there for a momentarily, so the bottom one will back. Let me go to the third one really quick. Third one is what express. Oh, this is the dimension. Oh, this is the easiest problem. So force is what? Mass times acceleration. Mass is m. Oops. Mass is m, and then acceleration, which is length, and then by time square, right? Okay, so this one is, what is the direction of acceleration at point 2? This is point 1. Acceleration here is going down, here it goes up, so and then here goes down. Okay, just for the record, I'll give you a quick review. Those of you who still ask me this question, why it's up, let me do it somewhere here. You don't need to do this, okay? But I'm just showing you. In this case, let me take just before the bottom line and just after the bottom line. Here the velocity goes this direction, here the velocity goes this direction, right? So this one is, let's say, VA, this one is, let's say, VB. The direction of acceleration will be what? Change in velocity, VB minus VA. By the way, magnitude is same, right? Because close, more or less same, because we have very small time, delta t. So in this small time, delta t, BB minus VA, VA. So what you basically do here is, delta t is a scalar quantity, so direction of this is nothing but the direction of this guy. So how you do this one is VB, and then you have to add of negative of VA, means you flip VA and then add with VB, right? So if you, let me copy here, so VB, let me copy it here. This is my VB, but VA negative is what? VA negative means go this way, right? And now you have to add this minus VA, you have to add to this. So tail goes to the head, so it goes here, right? So it goes here. So so the resultant will be what? From here to there. So the resultant velocity, this guy is basically VB minus VA. So the direction of this is going this way, of course it's going this way, right? Or vertically upward. Anyway, this is how you don't need to show all those. As long as you do this, you'll get full point, full 4 point. How about this one? A force of 1 Newton pulls west. 1 Newton pulls west. This is another easiest question. Pulls west, and the force of 1 Newton pulls north, so this goes north, north. What is the direction of the sum of the two? Sum of the two will go here, right? So basically you can write down, for since both are 1 1, it will be 45 degree north of west, or you can say 45 degree west of north. All right, okay. So let me do this. Now this is what I'm here to do basically. Here, this one I picked from chapter 1 of the exercise of chapter 2. The rocket blast off from the launch pad. Let's say this one is the launch pad. I call it like ground. From this ground, a rocket, let's say, blast off from the launch pad with a constant upward acceleration. So from here it goes up. Your acceleration here is, what is it? 2.75 meter per second square. It goes up and feels no appreciable air. Of course, there is no other forces, other resistance. When it has reached the height of 725 meter, so let's say this point, I call it A, for example. This is engine fail. All right, this is engine fail. So when this engine fails at a height of 725, I write here 725 from here to here, engine failing point. Where is it? The engine suddenly fails, and the only force acting on its way is now gravity. So what happens from here? The only force it acts is the gravity. So, but here the velocity is 0. I write here v0 along y will be 0, right? And at this point, with this acceleration, it will pick up some velocity. I call it v of y. Right? So once it gets the velocity v of it, the velocity keeps increasing from here to here because of positive acceleration. But at this point, when the engine fails, no force is there. So now only gravity comes into play. So what happens is from now it starts slowing down. Whatever velocity is here, it's like throwing with this velocity from this point, throwing up with this velocity. Now the question is, how much time will elapse after engine failure before the rocket comes crashing down to the launch pad? So what it means, let me use a red pen. So next part is from here, it goes up, slows down, becomes 0 somewhere, right? And then comes back again. So let me do it here. So it comes back again. Actually, it comes right straight from the same line. So not to overlap it, I'm just using it little sideways. Okay, so here what you do is the first part A. What are the given things here? From, let me make it even simple, from ground to point A. Okay, let's say, to make your life a little easy, hopefully you'll understand this one even better. Velocity OY, starting velocity will be 0. Your acceleration is 2.75 meter per second square, which is positive because the velocity is going, the direction of the velocity is also up. And now you need the velocity y at this point is what? What else is given here? The displacement is given here, which is y equals to 725, right? Those are the given things. Of course, 3 things are known. You need one more thing. You can easily get the velocity at this point. But you are not done. You need to get the time from here to there. So first you find out the velocity, which is, what's the formula for this, this, and this? So you have the formula set at the end, by the way. Okay, but you know, this is like this formula, and what you do is we use like x0 as 0 origin, so you don't need to worry about this. So simply vy square equals to v0y square plus 2ay times y. Okay, so so here we know vy square equals to v0y square plus 2a along y, this is a along y by the way, right, times y. All right, So this one, you need this one, Vy equals to, you take the square root, right? Square root, V0y is 0, of course, plus 2 times a is 2.75 times your y is what, 725. So your v along y will be, let me calculate, let me bring calculator. Okay, I'm not finding the calculator, so I'm using my phone. And by the way, as I said, you are not allowed to use your phone in your exam, strictly. But here it's okay. So here what I'm gonna do is 2 times 2.75 times 725, right? Now what you do is equal, and whatever it is, you take the square root of that thing. Square root of your answer will give you 63.14. So 63.146, let me use 5 meter per second. Okay. So now once you're not done, so once you get Vy, now what you need to do is, now you have from here the second case, which is from A to up, and from A going up and then going back to the ground. So initial point is this and your final point is this. So from, in this case, what happens here is you have your starting velocity. Now your v0 along y is this guy, this Vy, all right? This is now 63.15 meter per second. Now your acceleration is negative 9.8 meter per second square. Okay, so that is, oops, let me move a little bit up. Your acceleration negative 9.8 meters square. From here the velocity is going up, right? So starting velocity is this, acceleration is this. By the way, now what you need is how much time. So your time is the question, and one more thing is given, which is displacement. By the way, now your displacement is, from this point your displacement is negative because your velocity is going up, right? So only velocity is positive. Your acceleration is also negative, acceleration also goes down, your displacement also goes down. So your displacement is minus 725 meter, right? So now what you have all three quantities. You can simply pick the formula. So formula from your formula sheet, which is I'll write it for you, which is y equals to, which is y minus y0, but since you pick this as origin, so you don't need to worry about y minus y0. So y equals to v0y times t plus 1/2 of a of y times t square, which is, this is minus 725, and this one v0y is what, 63.15 times t plus 1/2 of minus 9.8 times t square. Let me simplify this. This will be 4.5, right? So 4.5, 4.9. So 4.9 is negative. Let me bring it positive on the left side, which is 4.9 t square. Oops, okay, 4.9 t square, and and this one also I want to bring negative, minus 63.15 times t, and then this one is already negative, already on the left side, so minus 725 equals to 0. This is a quadratic equation. So for quadratic equation, your t equals to minus b, which is minus 63.15 plus minus square root of b square minus 4ac minus 63.15 square minus 4 times a is 4.9 times c is minus 725 divided by 2 times 4.9. So if you simplify this, what you get is, let me do it, oops, let me do it here, so this one is, oops, all clear. This one is, let me start from this, which is 63.15 square, minus and minus will make plus. So by the way, this minus square will be positive, so I'm not worried about that negative sign. Minus and minus will be plus. All you have to do is add all those things. So plus 4 times 4.9, 4.9 times 725. 725. So whatever it is, you take the square root, of your answer, and that is 134.89, which is 134.9. Okay, so anyway, the point here is 134.9. now you have plus and minus. If you, so this is 63.5, which is plus. If this is minus, your time will be negative, right? So that you discard. I explained in the class why time comes negative, which can also be possible if the time is negative, right? But here we take only the positive sign, so we'll discard the negative sign. So here what I'm gonna do is this, and then I take only positive, which is, and then I add this one. Let me do it straight. Okay, plus 63.5 divided by, equals, you have to equal first of all, and then divided by, this is 9.8, right? 4.9 times 2, this gives you 20.24. So this is 20.2 second, right? You can also do, what you can do here is, you can get this displacement from here to here, how high it goes, right? So you can get this displacement and get the time, do it separately, get the time from here to there, and then again from here to there back. All right, so that will also give you the same answer. Okay, so you can do that way also. Actually, in your book, find how high it goes after the engine fails, right? This is also asked in your, let me use red, let me do it for you, this one also. Okay, so from here, let's say this is t1, and from here to here it takes time t2, for example, right? But to find from here to here, you need the height, this distance, isn't it? So let me use really quick here. So from this point, it's pretty much same thing, isn't it? So v0y is 63.15 meter per second. Your acceleration is negative 9.8 meter per second square, because it's still going up. Okay, but your final velocity Vy here is what? 0, because from here to there is 0. This one we don't know, but from here to here is 0. Okay, all right, so what else? 3 things is known there. You can easily find time 1, right? So 1, 2, 3. Okay, you can easily find time 1. The formula is what? Vy equals to v0y plus a times t, right? So Vy is 0 equals to 63.15 plus a is what? A is minus 9.8 times t. Let me use t1. Okay, t1. So from here, this negative comes on the left. This will be t1 equals, will be positive, and you divide both sides by 9.8. This is 63.15 divided by 9.8. So this gives me, what does it give? Oops. 63.15. Is it 63.15? Okay, divided by 9.8. 9.8 will give me 9.5 something. 63, what did I do? 63.15. Oops, I did 93.15. Hold on. 63.15 divided by 9.8 will give me 6.4 something, 44. Okay, so this will give you 6.44 second. Now this t1. So now from here to there, you need the total displacement, right? Or what you can do here is, you have to have 3 things. In this case, you have 3 things here already, but from here to here you need this displacement also, right? So when you get, how you get this displacement from here to here is same thing, right? unit, let's say y. Now just replace the another formula, which is vy square equals to v0y square plus 2ay times y, right? If you use this, you can find the displacement, which is, let me call y1, right? This displacement y1. So here your 0 equals to, this is 63.15 square plus 2 times minus 9.8 times y1. So this is basically this comes to the left, so your y1 equals to 63.15 square, 63.15 square, and then divided by 19.6 divided by 2 divided by 9.8, 2 divided by 9.8, so it's 203.5. so 203.5. so once you have this distance, by the way, this is in your exercise of your book, this is also asked. So if you have this distance from here to here, which is 203.5, so total displacement from here to here will be total your y will be 203.5, and then plus this one 725. This is whatever it is, you add 725 plus 725, this will give you 928.5. so now how high it goes is, from the ground it goes up to 928.5 meter. Okay, so now once you have this distance, right, now what you can do is you can get the total time t2. Here are the clues. Your v0 y will be 0, right? At the starting point, your v0 is starting from here to there. Okay, so starting point is 0. Right? Your acceleration a is negative 9.8, and your meter per second square, and your y is negative 928.5. by the way, you can take downward positive, which is your acceleration will be positive this side, and then your displacement is positive, but it doesn't matter since you are doing down negative everywhere. So when you take this as origin, your displacement will be negative, as well as acceleration also is negative. Okay. So now what you're going to do here is all you have to do is find out time from here. T equals to what? The formula will be what is your formula? Formula is y equals v0yt plus 1/2 of ay of t square. I'm repeating once again. So this is 0, so I'm not much worried. This is minus 928.5 plus 1/2 of minus 9.8 times t square, or this negative will cancel. So basically your time is t equals to 928.5. Oops. So your time will be, let me clear this, 928.5 divided by 4.9, right? 4.9, which is 189 something. But now you have to do what you have to do? You have to square root it. So square root of the answer, and that will give you 13.7. 13.76777 something, 13.7. so this is your t2, by the way, right? Time 2. So if you add this time 2 and time 1, you should get the same thing as this thing. All right, so when you add this, total time is just add this one, 6.44 times. So this guy, whatever is here, you add 6.44 plus 6.44. So this will give you 20.02. So total T is T1 plus T2, which is 20.02, sorry, 20.2 second. So it's again the same thing. So whichever route you go, this route, if you go this route, you have to get the time separately, both the times, and those two times, if you add it, that will give you the same thing. This one you get it in one shot, but you have to deal with the quadratic equation. If you go this route, I mean, you don't need to deal with the quadratic equation because all it has is basic. By the way, if you see here, y you get here, when you get the square root, you'll get plus and minus 13.7. So your time will be negative also here also, but you will discard that negative time. Okay, so this is your, oh, we're still only part A, so we need to do part B again. Okay, let me take out one piece of paper. So for part B, what is the velocity of the rocket just before it crashes? So you can do this, velocity of the rocket just before it crashes. You have all the information now. Since I took so long to do only one problem, it's almost 20 minutes or so. You don't, because I did like in several ways. So so from this one, all you have to do is from here to there. You can use this information here, this and this, but rather than finding your y, you find your Vy. All right, you can do that, you can go that route. So let's say, since you have already done this one, so let me use this one. So part B, what is your velocity? Okay, so part B, so from these information, what is the velocity here? Vy at the bottom equals to what? Your V0y is same thing, ay is same, this is your ay is, all the information is there. So use the formula Vy square equals to Voy square plus 2ay times y. So Vy is equals to V0y is what, 63.15 square plus 2 times minus 9.8, and then y is your minus 725, right? So okay, so this already is the calculation. So let me do the calculation, which is 63, okay, which is 63.15 square, 63.15 square, minus will be plus, so plus 2 times 9.8 times 725. So this will give 18 point something, but you have to get Vy with the square root, right? So square root of your answer. So this will give you 134.4, which is almost 135. So by the way, here's the trick here. Vy is actually, it's plus minus 135 meter per second. Now you take minus here. The reason is since it's going down, so the velocity will be negative because it's going down. Your positive is discarded. Okay, so since it's going down at this point, when it falls down, your final velocity Vy here is going down. So the negative is downward. All right, you can write it downward. Okay, you can write it downward, or you can use, just discard this positive, only negative. So you can do this way, this route also, or you can go the other route also, meaning starting from here, right? Start from here and end. So you can do like V0y equals to 0, rather than starting from here. V0y equals to 0, your y equals to negative 9.8 meter per second square. What else is there? So 2. So y is your total displacement from here to here, 725 plus whatever it is. What was the 928.5? So 928.5. So if you use this, you can get the final velocity Vy equals to what? Your formula is same thing, but your information has changed. So vy square equals to v0, which is 0 square, plus 2 times minus 9.8, but now your is 900 and what is it, 28.5. So if you do this, you'll get the same answer. All right, so here you have 2 times oops, this one is negative by the way because it's going down from here, right? So minus and minus will be positive, so this is 2 times 9.8 times 928.5, 928.5 equals to whatever, you take the square root of your answer, and this will give you 135, again the same thing, meter per second. By the way, since it's square, you have plus and minus, you take the negative, discard positive, discard plus. Okay, so well, I took so long to solve this problem because I did several methods. All right, so you don't need to do all those things, of course. All you need to do is only one method. Okay, so let me move to the next one, number 7, which is from chapter 3. It's projectile motion. This one is a simple question. I believe this is only 1-star problem, not even 2-star. I hope many of you have done this question right, but let me do it for you anyway. Okay, a ball is kicked up towards the post. There is a post here, kicked up towards the post with an initial speed of 31 meter per second, directed at an angle of theta equals to 60 degrees. Okay, above the horizontal. The ball strikes the post, top post. The top post, this is the post, 1.5 seconds after the kick. So how will you tackle this problem is the following. You're trying to find out the height, so all you do is find y. Take y. Okay, take y direction only, so make life easy. Take y direction only. So here this velocity, oops, it's a little longer, actually it has to be a little shorter. So it has 2 components, the y component and x component. This is your vy, actually v0y, this one will be v0x. In the x direction there is no acceleration, so initial velocity and final velocity will be same anyway in x direction, but y direction it changes because of the acceleration. So if you take only y direction, your v0, find v0y, starting velocity of y, which is v times y will be sine, right? Sine theta. So which is v is what, 31 meter per second. This is 31. Let me make it a little smaller. It looks really weird making the component velocity longer than the original velocity. Okay, so this is v, which is 31 meter per second. So your v0y will be, this is v0 actually, so v0y will be 31 sine of theta. So sine of 60, what is sine? Sine of 60, which is 0.866, and then times 31, so this will give 26.85. so I'll just write here times sine of 60, which is 26.8 meter per second. So this is your starting velocities. All you need is y, which is the height, right? And you know the acceleration along y, which is negative of 9.8 meter per second square. You need one more thing. What you need one more thing is, time is given, right? So it hits the post at time t equals to 1.5 seconds. So now you have 3 quantities there. All you need to do is find out the formula that has all 4 quantities, those 4 quantities. So which is y equals to v0y times t plus 1/2 of ay times t square. That's the formula. So your y, we need it, y is equal to h, that's what we want. And excuse me, v0, this is 26.8 times 1.5 plus 1/2 minus 9.8 times 1.5 square. It looks like the time is quite short. Actually, this is here, not there. Let's see. Well, I just gave random numbers, so I don't really. This is the first time I'm doing, so I don't even know what exactly is the answer. So anyway, let me simplify this, which is 26.8 times 1.5 times 1.5, and then plus, I'll just write it minus because plus and minus, and this will be 4.9. 9.8 by 2 is 4.9, and then times 1.5 square, 1.5, and then that is square. So let me see if I type it correctly. 1.5, 4.9, and 1.5 square. So this is 29.1, 29.2. Okay, meter. So okay, so 29.2 meters. So it looks like this time is quite short. Let me check. You know what? I'm a little curious. I'm just curious. Well, you don't need to do this. You can just continue. The answer is it's simple. Your first part A is only this. But what I'm a little concerned is actually this figure. Your height is somewhere here, not that side. Remember, it's a second equation T2. I told you in the class that it can have in two positions because of the square, right? Which is a parabola. Anyway, I'm not gonna rediscuss those things. I just wanna double check. Okay, this also wanna verify here. At highest point, at your highest point, your Vy will be 0. At max height. By the way, again, I'm not going to use the formula for the maximum height. All right. If I ask you the problem to find maximum height, you cannot use the formula, but you need to do it this way. All right. Because formula derivation, we did it in the class. That is just to show you how you tackle the problem. Okay. I don't like you just plug the formula. Write down copy the formula, plug the numbers, use your calculator, get the answer. That's not what I want. Okay, you need to know the conceptual understanding of physics. All right, not just putting the formula. Okay, so let's find out time. Okay, to get this height at the maximum height. All right, so your initial velocity is same thing, 26.8. I'm just a little curious. This time looks like more than this time. So your acceleration is again negative 9.8 meter per second square anyway. Okay, so what is the formula here? The formula is V equals to V0 plus AT. So V is 0, V0 is 26.8 plus minus 9.8 times T. So if you get time here, which is 26.8 divided by 9. T equals to 26.8 divided by 9.8. This is more than 1.5. So I'll show you here. So 26.8 divided by 9.8. So this gives me what? 2.7 seconds. So look here, 2.7 seconds. So just to reach here, it takes 2.7 seconds, right? So I should have given like 3 seconds or something time here, right? So that means this diagram is correct. But either way, this is just to show you, all right? So you actually the pole will be here, not there. Okay. So what else? So first part is done. Find the velocity of the ball just before the impact. So now you need to find the velocity at this point in magnitude direction. Of course, your velocity will be this way. So you have your Vx and Vy, right? Get Vy first. So for B, find Vy, all right, at this point. What will be your Vy? So Vy, you have initial velocity, you have everything there, same like before. Your V0y is 26.8 meter per second given. Your time is 1.5 second given. Your acceleration is negative 9.8, which you know. So you know all whatever, all three quantities, at least 1 2 3, all it is Vy. Use the same formula what I did here. So Vy equals to V0 by 26.8 plus minus 9.8, 1.5, right? So this will give me 26.8 minus 9.8 times, what is it, times 1.5, 1.5, so this will give 12.1 meter per second. So now you have the velocity here, 12.1 meter per second going up. So the thing here is, this is Vy. Now you need Vx, which is Vx. It's same as V0x because there is no acceleration on this direction. So your velocity will be this square plus this square. So V equals to square root of Vy square plus Vx square. Oh, you need to find Vx. Did I find Vx? Not yet. Okay, so what is Vx? Is V0x. So I'll do it here. Vx, which equals to V0x, which is let me see, V0 times cosine of 60 degree. So V0 is your 31, cosine 60 is 1/2, so this will be 15.5. So 15.5 meter per second will be your Vx, right? In this x direction it is 15.5, all right, meter per second. Okay, so this will give, what is Vy? 12.1 square plus 15.5 square with the square root. This will give, let me do it here. So 12.1 square plus 15.5 square. 15.5 square, I make it equals first and then take square root of the answer. So this will give 19.7 meter per second. All right, and the angle alpha is arc10 of Vy by Vx. This we don't need to worry here about negative sign because we know it is going up, so it will be positive anyway, right? So not minus. Actually this will be plus and minus of 19.6, right? But in this particular, since it's the first part, so it is positive, so you don't need to worry about negative. If it was here, it would have been negative, all right? So and then your angle would have been different. So I thought, like, I'm giving you this one, so I just want to make sure your angle, whether you do it like negative angle or or not, but accidentally it happened to be a little easier for you, which is, what is it, Vy, what is it, Vy? 12.1 divided by Vx. What is Vx? Vx is 15.5, tan inverse of this guy, so 12.1 by 12.1 divided by 15.5, all right, equals this one, arc10, what is it, 10, answer will give me 37.9. So so this is alpha equals to 38 degree with the 38 degree with the what axis? It's with the positive, with the horizontal, or with the ground, but this is on the positive side, so this is even easier. Okay, so this problem, in fact, you have to make sure if it is this way or this way. So again, you're lucky that it is on the first part, so your angle will be positive, alpha. All right, so let's go to the next problem. I know I'm taking quite long, but again, this should be done in about 15 minutes. All right. Oh, okay, I also took about 13 minutes, that's fine. 15 to 20 minutes. All right. So let's move to the next problem, which is this is from chapter 4. Actually, this is also from the book. I just changed a little bit, or it's your job to find out. Okay, what exact problem is this? All right. So this is another easier problem. R is given as 0.21 meter per second square with the t square in I direction plus 0.13 meter per s cube and then t cube in the j direction plus 0.12 meter 0.12 meter per second t in the k direction. Okay, so you need to calculate the velocity. Velocity v equals to dr by dt. All you do is derivative with respect to time. This is your r, so dr by dt. Just take the derivative. When you take the derivative, this will be 2t. 2t will give 0.42 meter per second square, and then you still have t there in the I direction, plus this will be 3t square, so 3 times 3 9 3 39 and then 0.0 m s cube, and then this will still have t square, which is in the j direction, plus there's only one t, so only this one, 0.12 meter per second. This is in the k direction. All right, so now all you do is find the velocity. Oh, in terms of ij and k, so but this is easier in 2 seconds. Oh, anyway, this is only 8 points, so in 2 seconds, so velocity at t equals to 2 will be, all you do is just you replace t by 2, so 0.42 meter per second square times 2 in I plus 0.39 meter per s cube, 2 square, right, plus you don't even need nothing here, 2 meter per second k. By the way, 2 seconds, so 2s, 1 will cancel here, this will be 2s, I write here square, so s square will cancel, 1s will remain there. So just want to make sure you have the proper units. Okay, so here it is 0.84 meter per second, and this one is plus, so you have 2 times 2, 4, 6, 3, 5, 1. Is this right? So 1 meter per second. And what else there? Plus, oh, this one is I, this one is j, plus, and then this is 0.12, same thing, meter per second along k. So this is your answer. That's it. It says in terms of I, j, and k in 2 seconds. So that's it. And B, you have calculated the magnitude and direction of the force on the helicopter in 2 seconds. Okay, so now to get the force, you need an acceleration, because force equals to mass times acceleration. So in other words, it is asking you to find the acceleration. So to find acceleration, which is dv by dt, right? So dv is this one, so you have to do the derivative this one once again, which is t is here, so this is as is 0.42, that is nothing. In and this is m per s square. This is in terms of in the I direction, plus this one is will be 2t. So this will be 40 times 2 will be 80, so 39 will be 2 less than 80, so 78. So 0.78 m over s cube, but you still have t there, right? And then j plus this is 0.12 meter. What's wrong here? No, this is 0 because there is no t. Okay, so if there's no t, it's constant. So constant means that will give 0. So there's no k direction. So what you can do is you can get the magnitude of acceleration here, all right, or you can simply do like force equals to ma and multiply by force. So F equals to mass times acceleration. So your mass is what? Mass is given here 3 kilograms. So multiply by 3 kilogram, which is 3 times 42 is what? 6, 12, right? 12 point. No, 1 point. Sorry. Okay, 1 point meter. There'll be kilogram also. So anyway, what I do is the mass will be kilogram meter per second square. I am simply writing here Newton in the direction of I. This is 1 plus this one will be 3. What will be 24 24 2 21 20 23. You can use your calculator. I'm just doing it without using calculator. And this is m over s cube, and there is no, did we get the magnitude? Oh, okay, we're gonna get the force. So m over s cube, and then t s cube, and then t. Well, there is kilogram also. I write here kilogram because of the mass. Kilogram is the kilometer per second cube, but you have t one more, so this will cancel and then it will be Newton. Okay, and then this is j. All right, this is force, mass times acceleration. This is in terms of I and j. Oh, but it says in 2 seconds, so you have to find the force in 2 seconds. Actually, you could have gotten acceleration in 2 seconds. First get rid of this t in 2 seconds and then find the force. I just used this one either way. So your F in 2 seconds will be 1.26 Newton I plus multiply this by 2. So 2 times 4 will give you 8. 2 times 3 will give you 6 point. 2 times 2 will give you 4.68. And now it is Newton because this t will be second one cancels, so this will be Newton, and this is j. You don't have to do this way, okay? You can just go from there. Okay, so now the magnitude of force will be 1.26 square plus 4.68 square with the square root, and this will give you this is x component and y component. So this will be 1.26 square plus where is plus 4.68 square equals to 23.49, and then you take the square root of your answer, and this will give 4.85. okay, 4.85 Newton will be your magnitude. And the direction, so your direction alpha will be arc10 of what is it, 4.68 divided by 1.26. So this is there already, so all I have to do is just divide by 1.26. this will give me 10 inverse of 3.84, and you do arc 10. What is it? Shift 10 inverse of answer, so this will give 75.4 degree. All right, so okay, so this is also not really that hard a question. All you do is simply do the derivative for velocity, and if it's asking you at a certain time, just replace the time by the given velocity. And since the question is also asking the force, so to find force you have to get the acceleration, and you can just get the magnitude here. Okay, you don't need to do finding the in the long way, but just get the magnitude and multiply by the mass, so it will give you the same thing for 4.85. And then angle, also the acceleration, the angle of acceleration and angle of the force will be the same, because force equals to mass times acceleration. So if you really go here, where is it? Here, right? So 2.34, if you do it 2.34 and divided by 1.26, right? No, what happened here? Hold on. 4.68. Oh yeah, you have to get 4.68, not no acceleration here. So if I get the acceleration here, so the acceleration is what? 0.42 I, and then in 2 seconds, this will be 2 times 8 is 16, 2 times 7 is 14, and 115, right? So 1.56 of j. So if you do like arc 10 of 1.56 by 0.42, this will give the same thing. All right, 1.56 by 0.42, 1.56 divided by 0.42 is the magnitude. So this will be this one. When you do 10 inverse of answer, this will give the 74.97. Oh, anyway, there's decimal little opposite. So okay, so you can do this way. All right, so and this one is the last problem, which it says in the following setup, two masses m1 and m2, so you have two masses are connected through a light frictionless pulley. The coefficient of kinetic friction between m1 and inclined, this one here, mu of kinetic is given as 0.31. That's mu of kinetic energy. The slope makes an angle of 45 degree here. Alpha equals to 45 degree with respect to the horizontal. Calculate their acceleration. So here, as I done in the previous video, this one is your t, and this one will also be t, right? Same thing. In the first part, if you draw a free body diagram here and draw a free body diagram, your mg will be here. So I'm not gonna write down mg. I just wanna write down here mg has two components. This side, which is force due to gravity, right? And then since this is going this way, so this has another frictional force also on the same direction, right? Frictional force F of k is also opposing direction, and T is the only one that is driving. So I'm not gonna show you all those things, all right, all those things, and then so on. But basically we have only these forces. So and at this point you have this m2 gravity going down, right? So all you need to do is here it's easy. The second part is easy. Second part is m2. So here the acceleration is going in this direction, right? Here your acceleration is going on this direction. So um, but this acceleration and this acceleration magnitude is same, because the string, they are connected, so whatever down it goes, same up it goes. So the acceleration remains same as long as magnitude is concerned. So in the first part, what happens here is t is more, so t has to overcome these two forces, t minus force due to gravity minus force due to friction is the total net force. This will give you mass 1 times acceleration. So this is your first case, and the second case is like this is higher. So on the second one, your weight, which is m2 gravity minus t, will give you m2 of a. That's it. So so here all you do is just find out force due to gravity, which is force gravity is what, mg of sine of the angle alpha, right? This is what we did on already in the class. I'm not gonna I'm not gonna redo all those things. Which is mass is, what is your mass here, m1, sorry, m1 2.5, or let me write down here f of k. I'll write everything together, since f of k, by the way, f of gravity is this value, I write here minus f of k is, this is only the magnitude, okay? So this is mu k times n, but n is mu k mg of cosine of theta. So basically I can calculate individually fg and fk and then just plug it there, or you just rewrite it. What you do is you just simplify this first. So if I simplify, this t and t will cancel. This will give you m2 of gravity minus fg, let me write it down, m1 gravity of sine alpha minus fk will be mu k mg cosine of alpha. By the way, this is alpha. What is m2 minus this equals m1 a plus m2 of a. What we need is the acceleration, okay? So we need this guy, we can take factor out. So basically if I take the factor out, your a will be m1 plus m2 of a. So if I divide both sides by m1 plus m2, your a will be m2 gravity minus m1 gravity sine of alpha minus mu of k m1. By the way, this is m1. Is it m1? Yeah, fk is m1 of gravity, what is it, cosine of alpha, and then divided by m1 plus m2. You're done. So all you do is just substitute the values. m2 will be 5 times 9.8 minus m1 is 2.5 times 9.8 sine of alpha is 45 degree minus mu k. What is mu k? 0.31. 0.31 times m1 is 2.5 times, I'm not writing units, okay? So 2.5, gravity is 9.8, cosine of alpha is, what is it, 45 degree divided by m1 plus m2, 2.5 plus 5. So all you do is just simplify these. 5 times 9.8, 5 times 9.8, let me show you, okay, minus 2.5 times 9.8 times sine of 45. What is sine of, oops, no, it's not arc sine, shift, okay, sine of 45 bracket close minus 0.31 times 2.5 times 9.8 times 9.8 times cosine of 45. Where is cosine of 45? Right, cosine of 45, bracket close. So that much, and divided by, I can put the whole parenthesis, but let me use equals to whatever it is, divided by this 7.5, right? So answer divided by 7.5. So this will give 3.5, right? 3.51. Okay, so your acceleration is 3.5 meter per second square, 3.51. All right, so you have the acceleration. So once you have the acceleration, all you do, well, this is part A. Once you have the acceleration, you can use tension. You can plug it either 1 or 2. So the 2 is a little easier because it's shorter, so you can just use it 2. So B. So 2 is, let me rewrite here. So 2 is what? T, I can kick it on the right. So m2 gravity, this I bring on the left, minus m2 acceleration equals T. Right? 5 times 9.8 minus m2 is again 5 times A is what? 3.51 equals T, or T equals to what is it? This is already there, so I'll do times 5, right? Times 5, and then I use minus and it becomes negative, but I'll make it positive. All right, times 5 times 9.8. 5 times 9.8. So this will give you negative. I can remove this. So 31.46 Newton. Okay, so this is pretty simple. You can also verify it. You can plug it at number 1 to make sure if this is right. Okay, so from number 1, T equals to what? M1A minus M1A minus f of g minus f of k, M1A plus this. So M1A is what? 2.5 times 3.51 plus f of g is yeah, it's quite long. Yeah, just check it yourself. Okay, just plug those numbers, you'll get the same thing. All right, so this is your exam 1. So we'll see you in exam 2 next. Bye.